Hello and welcome to the Avidyne Avionics webinar series. Today we're going to talk about the DFC90 Digital Autopilot Retrofit for Entegra-equipped Cirrus and Piper Matrix and Mirage aircraft, as well as Aspen PFD-equipped Cirrus 182s and Bonanzas. What's the DFC90? Well, it's an attitude-based digital autopilot. Again, designed for Entegra and Aspen-equipped aircraft. And it is designed as a slide-in replacement for the STEC 55X. But if you have one of the other STEC legacy models, like an STEC 30 or a 50 or a 60, we can also repurpose those servos and brackets as well. We utilize the PFD or the EFD Aspen. PFD that has an integrated air data and attitude reference sensor called an ADAHRS, so we get the digital attitude and air data information, which is going to provide a much more stable flight, way better tracking, such as in an ILS and during windy conditions and gusty conditions, and much higher reliability than flying off the turn coordinator. We're currently certified the DFC90 on the Cirrus SR20 and 22 with Entegra or the Aspen EFD-1000, and also the Entegra-equipped Piper PA46 Matrix and Mirage. But in addition, we've got STCs for the Bonanza and 182 with the Aspen EFD-1000. And again, with the STEC autopilots, any of these vintage, you got the 30, the 50, the 55, 55X and 60-2. We do need to repurpose those servos and brackets, and the airplanes have to have manual electric trim as well. Well, what's the DFC going to do for you? It's going to give you a much more precise flight using the ADAHRS information, fully digital. It's got air data coming in, better than just an analog pressure transducer. The precision of the inertial reference unit within the ADAHRS for pitch and roll. 10 times more reliability than the iron rotor gyro inside your turn coordinator. And overall performance and reliability improvements. Plus repairability too. It's a full-featured autopilot. All digital. Kind of has the same modes as like you'd find in a turbine class autopilot system. Of course, pitch and roll hold, altitude capture, airspeed hold, vertical speed, nav modes, GPSS, straight and level, approach modes. One of the nice features of the DFC90 is the unambiguous mode Annunciation. So unlike the STEC that has this monochromatic LCD display, so it makes it tough to tell, am I armed or am I coupled, etc. We've got color-coded buttons, so they're backlit in white. If the mode is armed, it turns blue. If it's coupled or engaged, it turns green, like you see here. And that also aligns with the display on the PFD. So the green is coupled, and the altitude here, in this case, is armed. And it shows up the same way on the Aspen EFD. So it's at a glance, it's much easier to tell what the thing is doing at any given time. We've added indicated airspeed hold mode, so something that the STEC 55X or some of the other STECs don't have. This gives you the ability to easily do flight level changes with a controlled airspeed. We've added a dedicated airspeed knob on the DFC90 and a bug right on the PFD, so you can set it and arm it, and off you go. There's your airspeed hold mode, so you would dial in the bug where you want it, arm the IAS. In this case, it's coupled, so we're flying an airspeed up to an altitude. The altitude is armed. When we get to selected altitude, which is in the pre-selector here, then we will level out at that altitude. It's definitely a more elegant way to execute a flight level change, and it works the same on the Aspen unit. You'll see a vastly improved flight director performance, making it much easier to hand fly, chasing the command bars here. You see here when they're green, that means they are the flight director is on, but the servos are not engaged. So with the better algorithms, with the smoother digital ARs, you're not going to be chasing command bars with the symbolic airplane here. And then, of course, if you turn on the autopilot, then it will turn magenta. This is another nice feature of the DFC90 is the synchronized heading bug. A lot of times, I try to remember that before I couple an autopilot, if I have a heading change, I spin the heading bug before I engage the heading mode. But maybe you're in a heading mode and they say, ATC comes on and says, take a right-hand turn, 270-degree turn. You can actually execute that with the heading bug by spinning the knob clockwise in this case instead of counterclockwise. So if you were to spin, and we're heading along at 330 degrees right here, if you were to spin to 240 in this case, a 270-degree turn, the S-Tech would lunge to the right as you tried to chase the heading bug, but as soon as you got beyond the lubber line here on the bottom, it would, of course, circle back and try to take the shortcut, which may not be what you were asked to do. In this case, we want to fly a 270-degree turn, and this will allow us to do that just by chasing the heading bug as we inputted it. If you want to turn left 90 degrees, then you would turn the heading bug the other direction, and of course it would track accordingly. Baro adjustment. You'll notice if you're flying along and you've got altitude hold set at 7,000 feet, and ATC comes in and says, hey, your new Baro is, pick a number, 2997 like it shows here. You know, now all of a sudden you're 20 feet high or 100 feet high, or pick a number. The PFD is smart enough, and the DFC90 will put you back to your coupled altitude without having to bump the vertical speed down. The DFC90 features a straight and level button. This was a first in the industry. This is a one-touch unusual attitude recovery capability. It overrides all the existing autopilot modes, pitch and roll, and automatically engages the servos and levels the aircraft in about a 2-degree pitch up attitude. It's a super safe and powerful safety enhancement to autopilots. We like to think of it kind of giving the same peace of mind for the non-pilot, similar to the Cirrus parachute. So if you've got a non-pilot in the right seat, hey, if something happens to me, if something feels weird or whatever, just push that straight and level button, and it's going to keep the airplane level for you, which is nice. There is a great video ALPA did from Dave Hirschman, where we flew the Cirrus with a camera ship, and he went out and rolled the thing upside down and then hit the straight and level button. If you go to YouTube and just look for ALPA DFC90, you'll see it, and it's a great video. I encourage you to check that out. The other great benefit of the DFC90 is envelope protection and full-time envelope alerting. Envelope protection guards against inadvertent autopilot-induced stalls and overspeeds, so you can't command the airplane into a stall or an overspeed condition. It'll prevent that from happening. The autopilot automatically acts to maintain 1.2 times VSTOL speed, so you've got a 20% margin. Envelope alerting is nice because it provides speed-based and attitude-based alerting even when the autopilot is not engaged. The ATAHARS is still doing the sensing, and even though the DFC90, none of the lights are green on it, it's still got power to it, and it's still doing computations. And in the event, let's say your autopilot's off and something happens and maybe you're incapacitated, with the envelope alerting, even with the autopilot turned off, you're going to get oral and visual alerts in the event that you approach an overspeed or an underspeed or an excessive bank condition for that matter. So it gives you the speed protection, and you'll get an oral alert.
Speed protection active.
So it gives you that added measure of safety, and you get the underspeed warning like you see here. One of the other nice things is there's no back course button, the reverse course button like you have on the S-Tech, because the DFC90 is smart enough to auto-sense the fact that you're flying a back course, so it'll automatically reverse sense the needles and fly it appropriately. Let's look at a couple of scenarios here. Flight scenario 1 is an indicated airspeed climb. So after takeoff, you're doing 90 knots. The pilot advances the throttle and commands an indicated airspeed at 130 knots. Typical climb-out speed for turbo aircraft. So the autopilot levels the aircraft, accelerates to the commanded speed, and then begins climb at 130 knots. So that's a great way to fly. As it says here, why use IAS versus vertical speed? Well, for climbs, the pilot's operating handbook recommends a specific climb speed to optimize engine cooling and deck angle for best visibility. And for descents, it helps you to arrive into the pattern at a specific indicated airspeed to integrate into the flow of traffic pattern. IAS also helps maximize ground speed, and it's great for engine out emergency used to hold best glide. So again, keep the bug on best glide if you're flying altitude hold or whatever. In the event you have an engine out or something, you can always just couple the IAS, and it's going to maintain that best glide airspeed for you. Here's a scenario with the STEC 55. We're intercepting an ILS with a crosswind. Typical ILS intercept with the STEC, so we're going to go from a nav to an approach mode, results in an overshoot and wandering in lateral and vertical axes due to the nature of analog rate-based sensor and pressure transducer. So as you can see, you intercept the ILS, but you kind of overshoot, and then maybe there's a gusting wind, and you eventually make it down okay, but there's maybe a little bit of searching for the altitude and also some drifting left and right. You got a nice quartering wind here. So with the DFC90, it's going to intercept rock solid, instantaneous control, and stiff crosswind. So the altitude estimators, gain scheduling, cross feeds, lift calculations, and range to go estimations provide precision capture and tracking in both axes. The digital ADAHRS provides instantaneous error correction. So it's not susceptible to the latency of the analog sensors like the older systems. Here's another scenario. This is a step down during a non-precision approach, flying the STEC 55X. So let's say you command 1,000 foot per minute descent to get down to your next step down fix. The flaps are extended, the nose is pointing down, speed's starting to increase. The throttle's reduced to avoid an overspeed. The autopilot anticipates the interception of the fix and gradually reduces vertical speed to intercept the pre-selected altitude, which takes a long time. There's traffic in the area and you're making radio calls. Now you're distracted. The airspeed's bleeding off as the autopilot tries to hold your altitude. And now here you are, you're approaching a stall spin kind of scenario. Not good. In that same scenario with the DFC90, first of all, it's going to descend and flare smoothly and crisply while the STEC doesn't, something that can get you in trouble. And if you run out of speed for whatever reason, you forget to add throttle back in or whatever, the envelope protection will give you oral alerts and also manage to keep you at 1.2 times VSTOL speed. And this is an interesting scenario as well, where here's loss of oxygen at altitude with the STEC in a scenario where hypoxia causes the pilot to fall asleep. So let's say something happened with your oxygen system, you're up at altitude, and now all of a sudden the pilot obviously passes out. The airplane's going to continue to fly until there's fuel starvation. If the engine quits, now the autopilot, it doesn't know, and there's no linkage there, so it continues to command pitch inputs to maintain an altitude that it can't hold. And what happens? Well, it drives you right into a stall spin, which is bad news. With the DFC90 envelope protection, even in the event the pilot's incapacitated and the engine quit, the DFC90 is going to exchange altitude for airspeed. So it's going to maintain 1.2 times VSTOL as the aircraft descends, and hopefully you've got some clear area where it gets you down below 13,000 feet or 12,000 feet to where the air's a little thicker. Maybe the pilot becomes conscious, realizes what's going on, can do an engine restart or switch tanks or whatever it takes to have a better outcome. So here's just a quick, it's kind of an eye chart, so I don't expect you to be able to see this greatly, but you can see the red versus the black. In comparing the DFC with all the legacy STEC systems, this is a good comparison. You can see all the great capabilities the DFC90 adds. Mainly it's rate-based, the straight and level. The envelope protection is terrific, and just flying off of a digital source versus an analog source is a dramatic improvement. Quickly on install considerations. First of all, here's the list of the STCs for the Cirrus, the Piper, the 182s, and the Bonanzas. Again, you must, to install the DFC90, you have to start with at least a 2-channel STEC Autopilot, because we want to use those servos and brackets. You need to have an manual electric trim as well. The Autopilot D-switches need to be removed. We'll repurpose the manual electric trim, etc. The existing circuit breaker needs to be a push-pull type, so if it isn't, we need to switch that. And we need to add installation of trim and flap sensing relays. And if you're on a 14-volt airplane, it would require a power converter. The PFD for the Entegra airplanes requires at least software version 8 or greater and Mod 55 hardware. So you would actually go and do an exchange of your EXP5000 PFD and get you an updated PFD and then swap out the STEC for the DFC90. This shows a good block diagram in the Cirrus configuration of the PFD. When all those were shipped originally with the dual 430s, while a lot of those folks have already upgraded to IFD 440s or something. You can see there's the turn coordinator, the pressure transducer, the external switches, autopilot disconnect, and your servos, etc. When you do the upgrade to the DFC90, we no longer need the pressure transducer. We no longer need the external autopilot and flight director switches because they're embedded in the box. We use the turn coordinator for comparison. It is required to be left in. And then you no longer need the relay switching. So a lot of folks are just leave the pressure transducer in there rather than bother yanking it out. Same with the relay. But usually there's a blank that you can put over the holes where the switches were, or if you're cutting the panel for some other reason. And then for the Aspen installation, you need to be at version 2.6 or greater, and so they've come a long way since then, but depending on the vintage of your Aspen unit. And again, here's a typical block diagram of, this is a Bonanza configuration here, and a lot of the Aspen installs have this ACU. It's a kind of an extra unit, a nav concentrator unit, which you may or may not have. When you do the DFC90 install, the turn coordinator is no longer required, the pressure transducer or the external switches, and you may or may not need the Aspen ACU at that point. And you may have IFDs or you may have GNSs. And you need to run flap sensing, so we need to know what position your flaps are in. That's great help for the overspeed, underspeed. The circuit breaker needs to be a push-pull type, so you want to upgrade that. One of the things with the DFC90 installation is it assumes you have an in-spec installation. So before starting the install, make sure your dealer is checking your cable tensions, your bridle cables, your clutch servo settings, and all the rigging to make sure that it's within spec. Because the DFC90 is so much more accurate, when everything's in spec, you're going to see it's going to be tight and right on rails. But if you've got servos and stuff that are out of spec or the cables are sloppy, then the DFC90's not going to perform as well as you might like. And we've got all that in the instructions for airworthiness. In the install manual. Pricing wise, the DFC90 has a list price of $99.99. It does require a Mod 55 for your PFD and or the Aspen EFD-1000 Pro with the DFC unlock. So the top 5 reasons for pilots to upgrade. Obviously, it's attitude based versus rate based, so how much higher performance. Flight envelope protection. Guards against autopilot-induced stalls and underspeeds and overspeeds. The straight and level button provides one-touch recovery of unusual attitudes. The airspeed hold provides a much more efficient way to make flight level changes. And it's easy to upgrade. if you have a 55X, at least it's a slide-in replacement. We're repurposing the servos and the brackets, which is where a lot of install time happens if you're putting in a new Autopilot. You're going to get a brand new warranty. The old S-Techs typically are expensive to repair, and most of them are out of warranty, so all those things are you need to consider. And we have extended warranties on all of our products. And current DFC90 customers are ecstatic. I mean, these are some actual testimonials from real customers. I didn't know what I was missing. It's way more precise, much more capable, solid like a rock, totally worth it. Flies like it's on silk rails. I love my DFC. It's much crisper, worth the wait. Flies like it's on rails. So, if you're interested in the DFC90, contact your Avidyne dealer or give Avidyne a call, and we'll work with you to find a qualified dealer that's convenient for you. There's the contact information, and I want to thank you for joining me on this webinar. Again, reach out to sales@avidyne.com for questions, and we'll get those answered for you. Thanks, and have a great day. So long.